So jumping back in, again, I mentioned that the we're not going to be able to cover everything in the R universe or environment in these 9 days here or during the codeathon. And so we've put together some resources to help you learn more. You can find these at the resources tab of the website. We also have videos from previous offerings of very similar class, and we have cheat sheets available. And we also have a help tab to the website. So that's daisy.org/help. Error messages can be a little scary. So if you're, kind of feeling a little flustered or like a little frustrated with some of the error messages you're getting, you may be able to find some of them on the website. And definitely ask questions in the chat or in Slack. Copying and pasting the error messages you get can be really helpful for us to try and diagnose what's going on. And so today we'll try to dedicate some time to making sure we debug any installation issues we're having. So for this course, we'll want to use the latest version of R or maybe one version previous. So basically a new version as of this year. So 4.4.1 or 4.4.0. That would be just, making sure you're caught up to kind of any changes that are going on in the different installation versions. We'll want to install RStudio, which is a integrated development environment. Just makes working with the R language a little bit easier. And if you're working on a Windows machine, you may get a message about something called R tools. If you do get that, this issue is explained a little bit more. You just have to download an additional piece of software, and that should get you up and running quickly. All right. So to summarize, the class website is here at daisy.org. It's going to have your logistics, resources, and help. So including, all these slides, the labs, all of that stuff. You can take the research survey here. And we also have a pulse check anonymous survey. So you can let us know how things are going, how you're feeling. That's definitely not involved in research in any way. It's just to let us know if anything's going on or you want to tell us about something you may want to cover again. So with that, I'm going to switch over to the next bit of information. But first, let's take a look at the website. So there are some logistics here. This is like times and dates and things like that, learning objectives, all that good stuff. The materials and schedule page, I think, will be really helpful for us. So the different modules we're going to cover here, we just covered the intro, but we'll cover various topics here, and you can find all the slides and then the labs associated with these here. We've also got a new data tab where you can find data sources. This will be more important when we get into the independent work. That resources tab we mentioned with cheat sheets and videos and things like that. And then the FAQ/help page. This is going to have the common errors and information about R tools if you need to install that as well. All right. So with that, let's get into basic R a little bit. All right. So for now, we're going to be working in something called the console. This is when we open up RStudio, it's going to look a little something like this. We're going to be working in the console side of things. So if I go over to my RStudio that I've installed, I haven't opened any files yet, anything like that. I've got this very scary license message that says it has absolutely no warranty in all caps. Don't worry, that's not hopefully they're going to be a problem. And it'll tell you a little something about the version and about citing R if you're interested in that. So you should see a little something like this. And for now, we're going to work in this part of RStudio called the console. And we'll talk more about RStudio in the next module. But for now, let me kind of shrink this down a little bit. And we'll keep going. All right, so its kind of most fundamental level, R is a calculator. So we can use the R console to do some math. We can do addition, subtraction, division, kind of traditional mathematical operations, but we can also do exponents with the caret or the double asterisk. R is going to acknowledge parentheses if we do math, which is pretty nice if we have something a little more complicated. And if we ever need to, the double percent sign is going to find the remainder of a division problem. All right, so if you're following along, again, you don't need to with these kind of live code sessions. We'll get to this in the lab, but if you want to follow along, you're welcome to. So let's try to evaluate some of the following. We'll go over to our console and we're going to start typing some stuff in. So I might do two, let me zoom in a little bit. Might do 2 plus 2 and hit enter. It's going to give me an answer there. It's going to tell me that's 4. I do 2 times 3 divided by 4. 1.5. So it's acknowledging that this part would come first. And we could do some exponents. All right, so that should be 16 minus 1. All right, pretty straightforward. It's doing some math for us. I was really surprised to learn actually that Carrie uses R as her calculator when she's just doing regular math for anything. I opened the calculator app on my computer. I was just very impressed that Carrie uses it for off the cuff calculation. All right. So let's talk a little bit. Yeah, I also have R open, but I forget that it can do that. So let's talk a little bit about some basic terms. We've started to plug in some numbers into the console, but a basic term we're going to use a lot throughout this course is object. So an object is something that can be worked on or with in R. It could be a lot of different things, but I want you to think of them as like nouns in R. So it could be a variable, it could be a data set, it could be a plot, it could be a ton of other things. But we can create objects in R and from, files from variables or from files on our computer. And we're going to use the arrow to create objects. So you might also see equal sign used, but generally that's not best practice. It still will work for most things, but we'll want to try to use the arrow here. So we were just doing some math, but the thing is it spit out that answer for me, but it didn't save it anywhere. So maybe I want to store the values, store the results of some kind of math problem. So maybe I want to store the value to use later. So I could say, all right, well, I want to create an object X that has the value 2. And pay attention to what's happening over here in my environment. When I hit enter, I don't actually produce anything in the console. I don't make any output, but it stores a value 2 in my environment that I can use later. So if I wanted to plug in that value to a math problem, R is like, I got this. It's going to plug it into as X into this equation and to that equation. So if I even just type in the value X, it will spit it back out for me. I know that that value is 2. All right, so let's do a quick gut check. What is an object? A, something I can touch, something that can be worked on within R, or a software version. Feel free to drop the answer in the chat, or if you feeling really great, feel free to shout it out. Yes, lots of B's. Excellent work, everyone. So something that can be worked on or within an R. All right, so we can create objects with text. They don't have to just be numbers. So these are going to be a little different. I'm going to need quotation marks if I'm going to use text. So I can't just type in Y is hello. It's thinking that I'm referring to some object. So I actually have to give it quotation marks if I want to give it some text. So let's do Y is an object. And we'll do hello world. We've got some text here. And again, just like before, I want to hit enter to store that in my environment. So remember, we made this X over here. I want to make it appear in my environment by hitting enter. So now I have a value or an object Y in my environment that I could see again if I just type in Y. And I could maybe use it later on. So I've stored it. So again, objects with text are going to need quotation marks. All right, so we talked a little bit about numbers, and we just now talked about text. We'll talk more in depth about the difference between these two, but for now, when we're talking about types or something called classes, numeric is going to be numbers. They're not going to have any quotation marks. And they kind of show up in this kind of like different color here. And character is going to be text with quotation marks. And by default, it shows up in green lettering, but you can see the quotation marks around it as well. So slightly different kind of variables or data that you might have inside R. All right, so we may already be running into some issues, and that's totally fine. So let's talk about some common ones that we might have. All right, so R is case sensitive. If I made an object with lowercase x and I give it uppercase X, it's not going to work. So, I made X here in my console. If I say, okay, well, what about capital X? It's saying that object is not found. I don't have an object called uppercase X. It treats them totally different. All right. So if you're copying and pasting numbers from, maybe some other data source, or you're just kind of copying and pasting things from slides or from somewhere else, sometimes we have commas in the numbers just to make them more readable. But commas are very important for something else. So they're going to separate objects and separate arguments, something we'll talk about later. And they should not be entered when entering big numbers. So if we have a number 3000 and it has a comma in there, R is going to think that that means something specific, and it's going to say, I don't know what to make of this statement that you gave me, this piece of code that you gave me, and it's going to give you an error. So if we tried to create an object Z with 3000, it's going to say an unexpected comma. I don't know what to do with that. So if we take that out, we should be okay. All right. This happens so often. So very, very important that we're aware of how to kind of fix this issue. Is if we give R an incomplete statement, we don't finish the thought, right? So it's here we have 10 divided by what, right? What comes next? If we give it an incomplete statement, R is going to think you're going to try to add some more stuff. And so it's going to give you this plus sign every time you hit enter. So I say, all right, 10 divided by, and then I'm just like, maybe I got distracted. I saw something cool outside and I don't know what I was going to add there. And I'm just like, I don't remember what I was doing. Let me just hit escape and I've got my pointer back. And now I can complete the thought and get my value output. So again, the plus means you have an incomplete statement. And if you hit enter a bunch of times, you're just going to keep getting plus signs. Just hit escape. You'll go back to normal. You can try that code again. All right, so let's do a little bit of practice. Let's try assigning your name to an R object called name. Scrunch this window down a little bit. All right, so if we're making an object called name, and you can ignore some of this stuff for now. We want to give it some values. And our name is text, right? So we're going to need quotation marks. All right. Great. So if I hit enter, I should have a object now in my environment called name. If I type that in, it should print it to the console for me. Little something like that. All right. Any questions about assigning these kind of simple objects here? We did some numbers, we did some text. Anything we want to reiterate there? Yeah, so usually you wouldn't really need to do that often. So one thing we will talk about is actually just cleaning up our environment, and I think we'll talk about that in the reproducibility module. But you can click this broom to get rid of objects to complete or to clean the environment. And I believe you could do remove, but we'll get into what is happening with that in a little bit. So as I mentioned, objects can be data sets. So like you could have a data set called my data or something like that. But if you had another data set that was similar, you might want to call it something different. So basically, you can't have anything with the same name. So that's actually a really good point. If, let's say, I wanted to make an object called name, and this was Carrie, now it overwrote the previous object. So now I don't have the object name with my name anymore. All right, anything else there? All right. And feel free to drop any questions in the chat. So, whoever is kind of talking at the time, the rest of us can address any issues, hopefully. All right. So we talked a little bit about, individual values or variables, but oftentimes we want to store more than one value, right? And use that to do some math or use that for something else down the road. So, a really important feature of R, something called a function, we'll talk about in a moment, is the C or the combine function. It's going to collect and combine single objects into a vector, something called a vector. And it's going to be mostly used for creating these combinations or vectors of numbers and of characters, text. So that code will look a little something like this. So if I was making an object X and assigning it some values, but more than one value, I could use combine and parentheses, and then separate all those values out with commas. So in practice, that would look a little something like this. I'm creating an object X, giving it my arrow, and then adding a C or combine, and stringing together some values. So let's say I want to do 1, 2, 3, 4. I could do 1, comma 2, comma 3, comma 4. And same thing, I can just hit enter, and it's going to look a little different in my environment here. So it's going to tell me that vector, the combined values that I put together, it's a numeric vector, and it's values 1 through 4. So it's got the first item, the second item, the third item, and the fourth item. And then it gives me a little preview of what those values actually are. And I can use it just like I would use another object in my environment. All right. So let's try to practice a little bit with this C thing that we're playing around with. So we'll use C to assign a vector called name2. So we want to create an object called name2. And we want to use combine to put together first name and last name. So kind of like this, but with text values. So let's do name 2. We'll do our assignment arrow, creating that object. And I can't just type out 2 pieces of text, right? I have to use the combine function to put it all together. So combine. And we'll do Ava and a comma and my last name, Hoffman. Okay. So I now have an object name 2 in my environment. It's character type or text data. It's got 1 element through 2 elements, so 2 distinct pieces of information in that vector. And those pieces of information are Ava and Hoffman. All right, so a little something like that. All right, so I mentioned this term function kind of briefly. So a function is a piece of code that is going to allow you to do something in R. It's going to take an action. You can write your own functions. You can use functions that come directly out of the box with R. So C is going to come out of the box with R. Or you can use functions that come from additional packages. We'd mentioned that a little bit briefly earlier, that these are like expansion packs of code for R. But I like to think of them like a verb. They're doing something. And so a function might help you add numbers together, create a plot, or even organize your data. There's a lot of functions for cleaning your data and to make some really nice visualizations that we'll talk about later on. Okay. So let's use some functions on our vector on some of these objects that we've been playing around with. So 2 functions that we might run into in our R journey are a function called class, which is going to tell us what kind of values an object contains. Is it a number? Is it text? Is it a character type class of data? And length is going to tell us how many elements or how many items is inside a object. So we created a couple objects here, so let's kind of play around a little bit with them. So I might ask, what is the class? And I got to use these parentheses. So what's the class of this name object that I made? It's going to tell me, oh, it's text. It's a character type of data. And I might be interested in seeing, all right, well, what's the length of X? It's got 4 items, 4 elements. So its length is going to be 4. Could also ask, what's the length of Z? It's just 1 value. It was that 3,000 that I provided earlier. Okay. So another gut check here. So what is a function? Is it a number or text? Is it a button somewhere inside RStudio? Or is it code that does something? Excellent. Oh, I love the C. I get it. Nice. All right. Yes, it's code that does something, right? A button inside RStudio is tricky because a lot of those do stuff too, but they're not technically a function. All right. Let's see how many before we. Okay. So we'll go a few more and then we'll take a quick break before we get into the lab part of things. So we can combine vectors. So we made these objects with a little bit, a number of items stored in them, and it's fine to combine them. You can take the C function and do vector, comma, vector. But all these values actually need to end up the same class. They either have to be numeric or they have to be character. You can't combine text and numbers. And if I try to, notice what happens here. So I've tried to combine name and that vector of numbers that I had. I get something a little funky like this, where I have text for my name, but then it also is having quotes around the numbers here. So it's saying this is a piece of text, but it's actually a number value, which is kind of funny, right? So it's treating this all as text data. All right. So let's do just a little bit more practice. What do we expect for the length of the name to object, and what is the class here? We might be able to guess just looking at our environment what the length of name to is here. But let's go ahead and give it a try. I think it's 2, right? Because I have items 1 through 2. It's got Ava and it's got Hoffman. So let's do length of name 2. It has 2 items. That sounds great. And it should also be character because it's got quotation marks, it's text. All right. I think one of the last things we'll cover before we jump into lab is that the hashtag or the pound sign is going to create a comment in the code. So if there's ever anything we don't want it to get run by the console, we just want R to ignore it, we can use the pound sign to deactivate that code. So, let's say I'm eventually, I'm creating more complicated bits of code that span multiple lines. We'll get into that in the next module, but if I just wanted to type in something like this, it doesn't give me anything, right? Because it doesn't actually evaluate that code. So this can be useful for leaving comments for yourself and also for turning code off if it's maybe causing you an error and you want to try to fix it later, but you want to kind of move on for now. You can use it to turn off that code. All right. So our lab, let's just kind of recap a couple things before we start it when we come back. But for now, let's take about 10 minutes, stretch your legs, get a moment to digest some of this information a little bit. And when we get back, we'll start to practice a little bit. So let's come back at 10 till the hour. And again, if you're having any questions, definitely encourage you to take a break and digest a little bit. But if you're having any questions, feel free to drop them in the chat or in Slack. All right, welcome back, everybody. So I just added the link to the lab. So that's in the slides here. It's the link that we just dropped in there. Also, if you go to daisy.org, to the materials and schedule page, come down to basic R, the lab files are located right here. So we have the lab. It's in a format called .rmd. This is going to open up in R. Don't worry too much about that file type for now. We'll cover that in a little bit, but the key and the keys kind of preview in HTML can be found here. So don't feel bad if you don't quite get the answer or maybe want to revisit something. It's available for you there. Okay. So what we'll do is recap some of the things we learned. So we can assign values to objects with the arrow here. New name is going to be on the left-hand side. We're going to use the combine function, or the C, to combine text, numbers, etc., into a vector. Can use class to tell us the class or the kind of object, whether it's a number or text. We can use length to determine the number of elements. And finally, we can use this kind of pound sign or hashtag for comments or to deactivate a line of code. So let's open up this file. If I go here and I click on this, it should download it for me. And if I go to my downloads and double click to open it up, typically that's going to open up in RStudio. You might have to tell it to open up in RStudio. And so don't worry too much about what's in here for right now, kind of the format here, but we're going to look at the questions and kind of walk through these. All right. So what we'll do is we will break out into rooms. So Carrie and I will kind of walk through the labs with you and do it in a slightly different way. Neither is more advanced than the other, but typically in Carrie's room, somebody will share their screen and everybody works on it together. And in my room, I'll go through the lab and do it on my screen. Hi. All right. So I'll share my screen. Anybody having any issues getting the file or having it open up in RStudio? Okay, let's figure it out. All right. Were we able to download the file? Okay. And then when we double click the file, what happens? Okay. So let's maybe try opening it from the file menu. So if I have RStudio open and I go to File and Open File, and then select it and open it. Let me know if that helps at all. You may have to, so if you're clicking on the link in the website, depending on like your browser and things like that, you may have to like right click and save it. And I'll drop that link in the chat again. All right. Anyone else still having issues? I wonder if, it might be something specific going on with your system. It might be worth checking with Elizabeth and seeing if she can help you out. Okay, got a couple. The instructions are to paste our code from the console to the gray boxes below. This is just to kind of keep a record of the values here. So again, we're going to talk more about this file format here in a minute. But for now, we're just trying to get a little practice running stuff in the console. So the practice, this first question, let's create a new object called my.num that contains any number. So I could type that in down here. Give us a moment to try that. All right. So my.num, it's going to be the name of my object. I want to give it some values, or in this case, just a value, any number. Let's give it the number 6. I feel good about 6 today. And hit enter. Okay. So I can see my.num is in the environment here. I can see the value it contains. So I feel pretty good about that. I feel like it ran and I stored it. I could type that into the console just to print it out. And maybe I want to copy and paste that code just so I can keep it for later. So this right here is so again, we'll talk about this in a little bit, but it's what's called an R Markdown file, and it's going to contain a mix of text and code. So anything in gray here is code, and we'll talk more about how you can like store pieces of that and actually run and evaluate that code in the next module. I know we're really excited to learn more about our Markdown files, but we'll get to it, I promise. Yeah, of course. All right. So yeah, I've stuck this here and for now, it like I want to think of it like just as a place to store my code so that I could come back to it. So I might want to save this file and hit the floppy disk or Command or Control S or up here to save, just to save that .rmd file. All right. So multiply my num by 4. So we know that R is pretty good at math. So maybe we can just take my .num and the times like asterisk symbol and 4. Let's try that. So we'll do my num times 4, 24. That does make sense. All right. So let's create another object called my car that contains 5 character strings or pieces of text. And so remember that when we're combining multiple things, we want to use the C, the parentheses, and separate them out by commas. All right, so let's create my car. We'll do combine and let's give it different cities. So we could do Seattle, do Baltimore, comma, Atlanta. These could be literally anything. You could do cat, dog, bird, lizard, something like that. Boston and New York. Hit enter. No, I see double quotes like this format a little bit more commonly, but single quotes is fine. Yep.
Okay.
Exactly. Yep. You can even mix and match a little. So if I did something like this, it would be interpreted the same way. Alrighty. So questions about creating my num and my car. All right. Well, let's get real wild here and we'll combine them. So we'll call a new object called both. We'll combine my num and my car. So this time I don't need quotes because I'm referring to an object, not just giving it, free text. Okay. So I see both in my environment. All right. What's the length of both? Could do length of both. And again, no quotes. We're referring to an object. It's got 6 objects. It's got those 5 pieces of text plus that number. So that should equal 6. That makes sense. And what class is both? Any guesses? Or you could put the code in and give me the answer. Yeah, it's character, right? So, which is a little confusing because we gave it a number, right? So that's a little tricky, right? But important to remember that when we use the C function to create vectors, they all have to be the same type. They all have to be either character or numeric. And so if R gets both, it's going to just make it text because you can make the number 1 text, but you can't make the city of Baltimore. You can't make that a number. It's a little hard to go the other way. So it's just going to make it all text, all character. And so then, if we try to take both, which is character, and we try to do some math on it, it's not able to do that, right? We can only do math on numbers. If we had 6 divided by 3, that would be just fine. And even if we had x, right? If we had this here, that's numeric, so that should be fine, right? It'll divide each by 3. But we can't do math on text. And you may see this error quite a lot, actually. And it's like the most non-intuitive error message of all time. It's what non-numeric argument to a binary operator. You may see unary operator, right? It is very jargony, but seeing something like this basically is like, hey, you can't divide the city of Baltimore by 3. That would be really weird. So you may see something like this. All right. Questions about any of the questions so far? Okay. So these practice on your own, especially if you have a little bit of experience. They're intended to kind of be extra time. You can do them either after the session or if you are feeling really good about these questions already as we're going through them, you can kind of skip ahead a little. But generally we won't go over those. They're in the key. The answers are in the key, so don't feel like you won't get to see the answers or something like that, but they're intended just as extra practice. Okay. And I'll kind of show my code here a little bit too. All right, I think we'll head back to the main session. All right, welcome back, everybody. So I think briefly we wanted to just quickly go over 1.5 through 1.7. So we'll recap that a little bit. So we made this object called both, and it had both a number and some text in it. And so if you were in my group, we made these pieces of text that were different cities, and we combined it with the number 6. So if we printed out both in the console, it looks a little something like that.
Yeah, Ava, can you go back to that part? Like just scroll up in your console to show it.
Yep, so that's
Like
right
how you
here.
made both. How you made both, even.
Yep,
Just a little bit
okay.
prior.
Yep, we could go back. So
Yeah,
for
thanks.
both, we combined my num and my car. Zoom in a little. Okay, so then if we take a look at both, looks a little something like that. All right, so to take a look at the length of this object, we could take a peek in the environment here, but we want to be getting some practice using functions. Might use length with parentheses and both. Okay, it's got 6 elements to it. All right, so both is not only is it an object, but it's also a vector. So yeah, great question there in the chat. So it's a special type of object called a vector. All right, and what class is both? Okay, so both is character, it's text data. And that's sort of maybe a little confusing because we combined a number and some text. And so, wait, why is it all text data now all of a sudden? Well, it's because a vector, which is what we have here, it all has to be the same class or type of information. So, if you have numbers and text, it's going to just assume that all of it is text because, the number 6 could be converted into text, but the city of Seattle, the city of Baltimore can't really be converted into a number. So by default, everything's going to end up as text or character data. And so then if I try to do some math on both, I'm going to get this very confusing error message, right? It's a lot of jargon. It's not really straightforward. But if you see something like this, non-numeric and some kind of operator, just this jargony way of saying it can't do math on text. So if I did something like Ava divided by 5, right? It can't do math on text data. So in contrast, if we had something like this, that works just fine. Okay, so very common error, especially if we're dealing with more complicated objects like data sets or data, we often call them data frames. When we're trying to do something with a column of our data and it gives us this error, it's like, what is happening? Maybe that column is actually not being treated as numbers, and we need to do something about that. We need to do some cleaning. All right. Okay, so hopefully we feel like we've got a little bit more of a feel for making objects, understanding that numbers and text are a little bit different, and especially this C here, this combine function. It's going to put together stuff into a vector. We'll get lots of practice throughout the class with that. Okay, so kind of going back to this idea of math and vectors, you can perform math with vectors, which is pretty cool. So let's say you were taking, and I'm going to zoom out just a little bit. we had this vector x that was just a whole bunch of numbers, right? 1, 2, 3, 4. And let's say we wanted to add 2 to all of them. I don't want to do that by hand. I don't want to go in 1 plus 2, 2 plus 2, 3 plus 2. I could just give it the vector and add 2 to all of them. Same thing with multiplication, same thing with division. Or if I wanted to go in and say, hey, add different items from another vector. So like let's add 1, let's add 10, let's add 100, and then let's add 1,000. I could do that as well. So math and vectors, they do play nice together. But as we saw, we can't do math on text. And this is often something, these may seem like silly examples, but this is often something we run into. We're trying to do math on a column of our data set, but it's saying, hey, this is text data. You can't do that. All right. So maybe what I want to do is save these vectors. I've been doing some addition, doing some math on these vectors. I want to save it as a new vector called y. So let's take what I did just up above. I can hit the up arrow and actually get the text that I just typed in. And maybe I want to save that as y. I want to assign it to an object called y. All right. And so in doing that, I actually replaced the previous object that was called y. I had hello world, I think. That object went away. So just being careful that, when you do assignments, you call things X, you call things Y. If you give it the same name, it's going to overwrite the original data, the original information. All right. So when we're thinking about objects, we're thinking about creating new data or new values in R. We do something called reassignment sometimes. And so this allows us to make changes in place. And so what do I really mean by that? So let's say, I'm taking that X, I wanted to add values to it, and I wanted to store those results. So I could store them in an object called Y. And so that means X is remaining unchanged. The original X is fine. I'm not doing anything to it, but I'm storing those new values in Y. Or what I could do is actually assign it or basically reassign it to X to make changes in place. Basically, I'm updating the X object. If I type in this here in the console, so I type in that. If I type in X, those values are unchanged, right? But if I do something like this, where I'm reassigning it, and I want to go back to X, I actually had updated, I reassigned that object. So now I can't go back to the original unless I run the code that I did before to create that object. So important to kind of know that when you're creating or giving it the same name here, we are updating the object, but sometimes that means we can't go back to the original, and we may want to do that. So, just thinking about whether I want to get that original object back could be important in some cases. All right, so let's talk a couple more functions. Promise there's not too many. And again, these are not necessarily important to memorize, but maybe just check back to these slides in case you're interested in, practicing with them later. But there's a function called str or structure. It's going to give you the structure of an object. So it tells us, what's the class, what's the length, and then gives us a little bit of a preview. So if I said, all right, well, I want to know the structure of this my car vector that I made, I can see that it's character type. I can see that it has 1 through 5 elements, and then it gives me a little preview of the data. So you'll notice it looks very similar to what's over here in the environment. Probably easier to just kind of scroll through your environment and take a peek at it. All right. So let's talk about another term, and that is argument. So arguments are going to be what you give to a function to tell it how to work. So arguments could be data like the number one or a larger number, or these values that I gave to the combine function. They can also be options about how we want the function to work. And typically these arguments are going to be separated by commas. And you could think of them maybe like an adverb because they're affecting how the function works, not to torture the metaphor too much, but they help modify that function so it behaves how you want it to behave. All right. So there's a couple of helpful functions that you may encounter that are going to help us kind of down the road, maybe a little bit more advanced if you have a little experience with R. If not, don't worry too much about all the nitty-gritty of these. But we could create vectors with a function called seek. And seek's going to have a bunch of arguments to it. So they're going to tell seek exactly how to work. The from argument is going to tell us what number to start on. The to argument is going to say what number not to go above. And then the by argument or the length out argument are going to tell us kind of how to divide up the numbers in between those two boundaries. So either I want you to go by an increment, or I want you to just give me this many numbers overall. So I could say, all right, I want you to spit me out a vector from 0, and the spacing here is not going to change the meaning. So I could have no spaces here. That's fine. I do like to space things out. I think that's a little bit nicer looking. I do from 0 to 100 by 5. All right, so I could get kind of a nice long vector without having to type everything out. I could, instead of by, give it length out. Okay, so there it's counting by 25. Okay, so again, a way to create vectors in a less manual way. All right. Similarly, we can use rep to make very long vectors. Rep is just a shorter version of repeat. So it can create character and numeric vectors. And it has arguments each or times or both. So what I can give to rep is a vector or a value and say, hey, I want each value repeated a certain number of times, or I want this many times of whatever I provide it, or I want both. And so I think kind of the best way to look at this is to just practice a little bit. So we could do, instead of seek, we could do rep. We could say, all right, well, I want you to repeat one of these vectors I gave it. Let's say we've got, let's use x. So we could repeat x. We could do times equals 5. Okay, so it basically took that vector and did it 5 times. Or we could do each element 5 times. So it just changes the order a little bit. Again, just some functions to do things a little less manually. And again, a little bit more advanced. All right. And sample can be really handy for creating numeric vectors that are a random sequence from some population that you want to sample. So let's say you have any number of values from 1 to 100 and you want to take a random selection. So sample can be helpful for that. So using some of the functions we've just previously learned, we might want to create a sequence from 0 to 100 by 1. This is going to be numbers just 0 through 100. And maybe we want to sample. We want to sample from that sequence. We want to draw 5 samples. And we want to sample with replacement. So what does that mean? That means if we're drawing samples from the seq.hun pool, if I draw, let's say I drew the number 51, does that number go in the trash or does it go back in the pool to be sampled again? So sampling with replacement means I can draw that number again. It's not likely because it's, 1 out of 100. But if I drew it again, that wouldn't be, that's possible that I draw it again. So replace equals true. And this true is in all caps, which distinguishes it from a object. So true is a special type we'll talk about in a little bit called a logical. Okay. So these are a couple of functions and kind of concepts and things like that that come with R straight out of the box, but we're actually going to be installing some packages throughout this course, and they're going to add more functionality, especially for data cleaning, wrangling, and plotting. And we can think of these like expansion packs. And so installation is typically done once for every major installation of R. So this could be like from going from version 4.2 to version 4.3. We don't need to install stuff that often, but we might need to occasionally. And so an important package we're going to use is called tidyverse. And so this is you can think of it like a dialect of R almost. It's going to make data cleaning and wrangling a little bit more intuitive, a little bit more straightforward. And this kind of tidyverse package is actually a meta package. It's going to include a lot of really useful sets of code, as I was saying, for import, wrangling, visualization, all that good stuff. And so actually, we're going to get some practice with this in the lab, but if we wanted to install something else that doesn't already exist out of the box, these expansion packs, we could use the function install.packages, and then we could tell it what package we want to install from the internet. In this case, we'll want to install a package called tidyverse. And that's going to have quotation marks. Okay, so that's sort of like installing an application. We install Microsoft Word, we install Chrome or something like that. We don't need to do it that often, but we do need to load it. So you install Word, you install Chrome, you actually have to open the application, right? And you open it pretty much every time you turn on your computer, right? So similarly, if we want to use tidyverse, we need to load it when we start R. And so we use a function called library to load up packages. So let's say we started R, we want to get tidyverse ready to use. We would say library tidyverse. Okay, and this is a little tricky, a little confusing, but the quotations are optional with library. Okay, so here's how I like to think about it, right? So installing is like you're installing the light bulb. It doesn't have to happen that often, but library is like turning the light switch on and off. You're just getting it ready to use. You're basically loading, you're turning on the light so that it can be, used in your house or something like that. All right. So this is the end of well, we'll do a little bit of lab, but mostly the end of the basic R module. So important to think of R being able to function as a calculator. We can use the assignment arrow to assign values to objects. We can use the C or the combine function to combine values into vectors. Length, class, and structure are going to tell us information about an object. And then these functions seek, rep, and sample are going to be a little bit more complex. They're going to help us create customized vectors. And very important, install.packages and library are going to be able to install and then load packages respectively. Okay. I do want to pause there to see what questions we have before we get a little bit more hands-on practice. All right. Well, if that is making some sense, let's go ahead and go to the second part of the lab. So hopefully you already have the file open and there's no need to go hunt that file down. We'll get a little bit more practice, and especially important that we install the tidyverse package. So let's go ahead and try that. All right. Hey, everyone. How we doing? Great. Maybe ready for a little more practice? Awesome. All right. So I'm heading back to the file I had open earlier. All right. And I'll give us a minute maybe to create a vector with elements 1, 10, 100, 1,000. Call it Z. Give us just a moment to try that, and then we'll talk about it. Yeah, part two is in the same file. So we did, remember we were talking about like division and how that's a little funky. If you go past the practice, so this is again, is just meant to be kind of independent. If you are feeling really confident, you're working ahead a little bit, you're welcome to kind of try the additional questions on your own. But part two is below that. All right, so let's try this a little bit. So let's create a vector with elements 1 through 110, 1,000, or 100 and 1,000. We'll call it Z. We've got Z here. We're using that assign arrow. We're combining 1. We've also got a 10. Oops, 10. We've also got 100. We've also got 1,000. All right, got that stored. All right, we want to multiply each number in Z by 5. So we could do that manually, but we could also just multiply the vector, right? All right, I think that worked correctly. Doing a little mental math just to gut check myself. So 1 times 5 is 5, 10 times 5 is 50, and so on. And these values aren't saved anywhere, but maybe I could save them as an object. I'm going to call it Z5. Very original here. If I wanted to store those for any reason, I could do that, but I might want to give them a new name. Okay. Anyone having any issues with the multiplication or creating this object called Z? Yeah, it's totally up to you what kind of convention you like. I think underscores generally like are a little more common to see,
I see.
but the dot is fine. I think the only reason I wouldn't use the dot is in like Python language, that means something very different.
Mm.
So that would mean like chaining methods together. Yeah, that might confuse some people, but it's generally not a problem if you prefer to do it that way. I personally am a fan of underscores, but all right. Let's create a vector called int vect that starts with 1 and goes up to 10. We could use seek to do that. That'd be really nice instead of having to type them out like this, right? Like that'd be kind of annoying. We could do that, but we want to maximize our efficiency. So we could do, let's type down here, int vect, and that is sequence from 1 to 10. What does that look like? Let's print it out. Looks good. All right, and we could be real sneaky here and even take out. So this first part of the argument is actually the name of the argument. And sometimes R is pretty good at guessing what an argument is. So it's here, I could cut that out and it says, okay, well, the first value I give it should be the from, and the second should be to. It should give me the same thing. We'll talk more about that again in future modules. Okay. And so we created this thing int vect. But what is the length of this vector we just made? What is the length of int vect? What is the length here? What do we think? Excellent. Yeah. I feel like R is not gonna lie to us, right? Yeah, yeah. Sounds like in the chat. Yeah, somebody else got 10. Anyone getting anything else? It's actually good. Sometimes we have errors. They're actually really good learning opportunities to figure out, what might be happening. R can sometimes be a little tricky. Sometimes we swap the arguments. All right, let's do length int vec just to kind of confirm. Sweet, it's 10. And I can also check that out here in the environment. And I can see it's got elements 1 through 10. I can take a peek there and kind of determine that without using any code, but always good to confirm. Okie dokie. And so then lastly, let's make sure we install the tidyverse package using install.packages tidyverse. We're going to load this package using library tidyverse. And yeah, you can restart our studio. That's fine. It just kind of clears up everything in the console. And so I already have Tidyverse installed, so what happens for me might be a little different for you. But I don't think it'll hurt me to update. All right. You get a little bit of a message. It's trying to contact this repository of packages called CRAN. It'll download the code and install it. And then really cool what happens when we load Tidyverse. And again, the installation might take a little longer. A cool thing here is it says it's attaching core Tidyverse packages. There's a bunch in here, which are pretty exciting. Lots of cool stuff. Don't worry too much about the conflicts. All right, so take a minute, make sure that the installation is working okay. And if you're having any issues with the installation of Tidyverse, make sure you let us know. Drop any errors you're getting in the chat, and we'll try to diagnose it.